Hey, welcome to Algebra Made Easy with Bogdan Majewski. In this video, we'll be going over mistakes that students like yourself tend to make when working with rational expressions. So let's dive into it. So the first mistake that we tend to make is canceling terms instead of factors. So this is a very common mistake that you would make when working with rational expressions. You want to see common factors instead of common terms in order to proceed with cancellation. So what that means is the following. Let me start with this beautiful example. So you have this trinomial divided by binomial as a rational expression. So 2x squared plus 13x minus 7 divided by 4x squared minus 1. So the tendency here is to cancel terms. I have seen so many mistakes like that when I marked over the years thousands of tests. Students make the same mistake over and over because they don't pay attention. So hopefully after this video, you will know that this is a mistake that you cannot afford to make. So what they do, students who make mistakes, they do observe that 2x squared and 4x squared is a like term. So they cancel it by 2. They also cancel x squared on top and bottom, and they get that result, which is a wrong step. So please avoid canceling terms. You have to factor first. So let's go over the same question one more time. So we have this trinomial on top divided by binomial, and then we proceed to factoring. Remember the video we did in the past? We showed you how to factor and then how to reduce the expression. So 2x minus 1 on top and bottom becomes a common factor. So when you factor first, then you cancel, you cut, and you reduce the expression so that it is correctly done. So hopefully by now, these mistakes, you will keep that in mind. That's a very common mistake what people tend to do, and you will avoid that. In case you get stuck, let's say you're working on questions by yourself and there's no one to help you immediately, recall any fraction type of question that you can handle in your mind. So pick some simple numbers. For example, 6 plus 5 divided by 2. When you add on top numerators, so you have 11 divided by 2, so you know that this is the right equivalent value. 6 plus 5 over 2, it is the same as 11 over 2. But if you went to do a mistake and you say, I want to cancel 6 and 2, dividing it by 2, because that seems to be the common factor, then you would receive 3 plus 5 on top. 3 plus 5 is 8. Divided by 1 is 8. But you know 8 is not equal to 11 over 2, right? So this is bad idea. This way you can always verify. So recall numbers and do it and see if you get the same results. If you do, that means you're on the right track. If you have two different answers with the same simple fraction questions when working with numbers, then you know that's the red flag. You should avoid a mistake and you correct immediately. The next common mistakes number 2, forgetting domain restrictions. So what we do, oftentimes we try to solve the question, we quickly factor, we reduce, and then we do the restrictions, which is already too late. You have to do the restrictions after you have the factor statement. So in this question, look at this beautiful binomial. Difference of squares on top, 9x squared minus 4 divided by 3x squared plus 10x minus 8. So you factor it first, right? So you see the factoring step right here. And then you have identical binomial, 3x squared minus 2 on top and the bottom that you want to simplify this. And when you do, and then you say now restriction time, this is too late. This is incomplete. To solve the restrictions at this point is already wrong because you're missing the 3x minus 2 term. You have already canceled that. So let's correct that mistake. So you would get this question done in incomplete form if you have chosen to reduce, to simplify, and then do the restrictions. Restrictions are to be taken care of first. So you factor step 1, then you do the restrictions as we did in the previous video. So now your denominator is 3x minus 2 times 4 plus x. So the whole product of binomial 3x minus 2 times x plus 4 needs to be taken care of when looking for restriction. So solve each binomial separately. Say 3x minus 2 cannot be equal to 0, and x plus 4 cannot be equal to 0 because the product of those two cannot be equal to 0. So when finding the solutions, you will say, oh, now I know. X is not equal to 2 over 3 from the first part, and x is not equal to negative 4 because you would solve it. X is equal to negative 4, therefore not equal because you're saying not supposed to be equal to 0. So you're solving in indirect fashion. You say let this binomial not to be equal to 0. Therefore, the solution is not to be equal to that number. And this defines restrictions. So hopefully that makes sense. So now you have two mistakes that you cannot afford to take. Canceling terms and then doing the domain restrictions at the end of the process. And then mistakes number 3, sign errors in factoring. So this is a difficult case because it requires of you the knowledge of factoring out -1 from binomials. So let me walk you through this example. What you can see is -2x squared plus 7x minus 3 on top divided by x squared minus 9. So if you were to factor this, which most of you can at this point, you would be tempted to make a mistake because x plus 3 and negative x plus 3 seemingly look the same, but they are not. And when you choose to divide both binomials that are not really identical, then you're committing a sign error. So you're doing it wrong. So be careful. You can only reduce identical, like twins, like binomials or terms. They have to be exactly the same, like term for term. So how to correct this problem? You would proceed to factoring and you will do the factoring correctly as we did already in the step above. But you don't want to cancel now because x minus 3 and x plus 3, negative x plus 3 rather, and x plus 3, they are not the same. So what you would do, you would take out -1 from the first binomial by showing it right here. So when you take out -1, you have positive x inside, and that positive 3 becomes -3 because you take out -1. -1 outside means positive x inside minus 3 inside now. And all of a sudden you say, hey, I have identical binomial x minus 3 and x minus 3. So you proceed with the cancellation, and then you're left with negative, distribute with this bracket will give you -2x, and negative times -1 will give you positive 1. So this is good answer. It's not the best looking. So in mathematics, you want to avoid a situation where your expression shows up with negative sign in front, especially a rational expression, because later we may by mistake consider that this is a negative sign in front of entire expression. So in order to avoid those mistakes, you want to simplify it by changing the order. So you put 1, the positive term first, and then you throw in behind the one that was in the first place. So you just change the order in which you add, which doesn't make any difference when you add two numbers. So it doesn't matter in which order you do. Add them together. So 1 minus minus 2x, rather. So 1 first, minus 2x. It's much better statement than negative 2x plus 1, especially when working with rational expressions. So hopefully that makes sense. And the denominator stays the same, of course. So now you have learned the 3 mistakes to avoid. And when you do questions starting from now on, you will be a pro. You won't be making the same mistakes that most people would without learning them and how to avoid those mistakes. So as a practice questions, I want you to do those 3 questions. Do them in 2 different ways with creating a mistake, recognizing what mistake you did make, and then complete that correctly. So jump in to the practice right away at the end of this video. And also don't forget to share this video and subscribe to the channel. See you next time. Have a good one.